Honors Geometry students, welcome back. Today we are going to talk about how to perform rotations and reflections. And again, we're hanging out with Learning Target 2F, where we are comparing and creating transformations in a plane. Our essential question is, how can I perform rotations and reflections? All right, so we're going to start with a reflection. A reflection is a flip or a mirror image. Okay. It's an isometry, meaning that it's going to be the same size, same shape, but it reverses orientation. Notice our original pre-image, A, B, C, D, we name those letters clockwise, but A prime, B prime, C prime, D prime goes in the opposite direction and is going counterclockwise. So that's what we mean by when we say reverses orientation. All right. So, example number 1, we are going to take this triangle KLM and reflect it over the x-axis. All right, so remember the x-axis is this horizontal guy. All right, so we can do this one just by plain old counting. So, we notice that point L is hanging out 1 unit above the line of reflection. So, L prime is going to be 1 unit below. Okay, same thing with M. So M prime is going to be 1 unit below. And then when I take a look at K, that is 5 units above my line of reflection. So I'm going to go 5 units below. And here's my K prime. You'll notice that L was hanging out at 1, 1. And now L is hanging out at 1, negative 1. M was hanging out at negative 3, 1. M prime is hanging out at negative 3, negative 1. K was hanging out at negative 2, 5. K prime is hanging out at negative 2, negative 5. If we do a quick comparison of the corresponding y coordinates, we notice that the only thing that happened is that the y coordinate changed signs and the x coordinate stayed the same. So if we wanted to write a rule for reflecting over the x-axis, our rule would be xy gets mapped to x negative y. So this just means change the sign on whatever your y coordinate is. So if it's negative, make it positive. If it's positive, make it negative. All right, next one, we are going to reflect over the y-axis. Y-axis is this vertical guy. Okay. We notice that the pre-image kind of hangs out over that line of reflection. That's okay. So C is hanging out 1 unit to the left of my line of reflection. So C prime is going to hang out 1 unit to the right of my line of reflection. Okay, B is 5 units to the right, so B prime is going to be 5 units to the left. A prime it was 4 units to the right, now it's going to be 4 units to the left. Okay, take a moment, pause the video, see if you can write your own rule for reflecting over the y-axis. So XY gets mapped to. Okay, pause the video, see if you can make your rule. Okay, let's compare. So A prime was hanging out at negative 4, negative 2. B prime was hanging out at negative 5, 5. And C prime was hanging out at 1, 3. All of my y coordinates seem to be the same, but if I compare my x's, they all switch signs. So my x's are switching sign, so negative x comma y. All right, cruising along. Now we're going to reflect over the line x equals 1. X equals a number is always a vertical line, and since it's x equals 1, we have a vertical line hanging out through 1. All right, so in this case, probably the easiest thing to do is just that counting piece again. So A is 2 units to the left of my line of reflection. So I count out to the right 2 units. Same thing with B. B was 2 units to the right. Now I'll go 2 units to the left. D was 1 unit to the right, so D prime will be 1 unit to the left. And C is 5 units to the right, so C prime will be 5 units to the left. And here is my figure. Okay. Not super important for today, but in the future, if you ever wanted to write a rule for reflecting over x equals a number, so in this case h, the rule would take x, y coordinates, and you would take 2 times that x value. So in this case, it would be x is 1, so it would be 2 times 1 or 1, minus x, comma, y. If you ever wanted to reflect over the line like y equals a number, so y equals j, for example, xy would get mapped to x, comma, 2 times j minus y. That's not something you'll have to worry about for today, but later on when we're writing our own rules, when we're throwing a bunch of stuff together, that might be something good to keep in mind. All right, one more reflection. And here we're reflecting over the line y equals x. All right, so y equals x, if we make an xy chart, because sometimes we forget about how we graph this stuff because we haven't graphed a whole bunch in this class. Y equals x is any coordinates where x and y are the same. So 0, 0, 1, 1, -5, -5, all of those are going to be hanging out at my line y equals x. So it is this diagonal guy hanging out here. All right. So it's harder to count now because if we take L and drop it down perpendicularly to this line of reflection, however many units that is, I need to count out that way as well. And it's kind of hard to do because I'm not hitting directly on the grid lines. But L prime would be hanging out somewhere roughly here. So we could construct a perpendicular to our line of y equals x through point L. We could duplicate our segment hanging out here, so L to our line of reflection, make sure it's the same over this way. Otherwise, we can use our rule. So xy, when we reflect over the line y equals x, gets mapped to yx. So meaning they just flip-flop. So k was hanging out at -3, 5. So k prime is going to hang out at 5, -3. Change order. J is hanging out at -6, 2. So j prime is going to hang out at 2, -6. And we will connect. There we go. Okay, and you always want to eyeball it once you're done. Make sure it makes sense. Does it look like a flip? If you were to fold that paper over, or fold your figure over that line of reflection, would those two figures line up? Okay, one more line of reflection. We're not going to actually do this, but something to keep in mind if you want to reflect over y equals -x. So we have a little diagram here. That would be over this diagonal line that goes the opposite direction. So in that case, xy gets mapped to -y, -x. So the coordinates flip order and we change the sign on both. All right, so that's reflection. We're going to continue on now and we're going to take a look at rotation. A rotation is an isometry. It does not change orientation. I want you to think about a twist or a turn. Okay? Unless you are told otherwise, the center of our rotation is the origin, otherwise known as 0, 0. So in this case, our origin hanging out right here, that's the center of our rotation. Okay? You always assume that rotations are counterclockwise, CCW, okay, unless told otherwise. Okay, so let's talk about the relationship between clockwise and counterclockwise. In example 5, we're talking about a 30-degree clockwise rotation. Let's figure out what that same rotation is counterclockwise. All right, so we're starting with our axes. And if we're going clockwise, let's say we're starting out here. Let's say we're moving 30 degrees in this direction, and we're going clockwise. We want to know what would the corresponding counterclockwise rotation be. Now keep in mind, all the way around is 360 degrees. So we've already taken up 30 degrees in the clockwise direction. So if we take 360 minus 30 degrees, a 30-degree clockwise rotation is a 330 degree counterclockwise rotation. Okay, cruising ahead. Okay, this one we are going to rotate triangle ABC 90 degrees about the origin. So we're going counterclockwise. So we want to rotate the figure this way. We think about 90 degrees, that's like a quarter turn. Okay, so my center is the origin. So I can connect point A to my origin. And it's a 90 degree rotation, so I'm going to go perpendicular and count out the same number of spaces. All right, since I'm just traveling perfectly diagonally across one grid, pretty easy to figure out, or we can figure out that A prime is hanging out here at -1, 1. Okay. It would be difficult to do for the rest of these, so let's talk about a rule. A 90 degree rotation about the origin, we're going to take xy and map it to -y, x. So what's happening is that we flip the order of our coordinates. So instead of xy, it becomes yx, and then you change the sign on the first one. So A is hanging out at 1, 1. A prime, we flip the order, still 1, 1, and change the sign on the first. B is hanging out at 1, 5. So B prime, we change the order, so 5, 1, and change the sign on the first. So B prime is hanging out at -5, 1. C is hanging out at 5, 2. So C prime, we change the order, 2, 5, change the sign on the first for -2, 5, and there's my C prime. And that's a rotation 90 degrees counterclockwise about the origin. All right, so let's come up with a list of rotations about the origin. So, because we won't always be dealing with just a 90 degree rotation, but for the purposes of our class, we will be basing it on a 90 degree rotation. So 90 plus 90 gives us to 180, another 90 would give us to 270. Okay, so a 180 degree rotation would start at xy and rotate 90 degrees to get us to -yx. Remember, we changed the sign and we changed the order and changed the sign on the first. So now we're going to change the order, so x, -y, and change the sign on the first. So xy gets mapped to -x, -y for a 180 degree rotation. Okay, our 270 rotation, we're going to apply 3 90 degree rotations. So xy to go 90 degrees would become -yx. To go another 90 degrees would be -x, -y. So that's like our 90 degree rotation, our 180. All right. And then last but not least, we are going to flip the order and change the sign on the first. So a 270 degree rotation would take xy and rotate it to y, -x. All right, so that's about it for our rotations. Your homework would be to try out the worksheet either in Notability or on ClassKick. Please reach out if you have any questions. I'll see you online. Bye.